Okay, good morning, everybody, and thank you for being here. I'm Carlotta Zeppilli from University of Pisa, and today I will talk to you about Oreopithecus bambolii, a fascinating but controversial primate from the late Miocene. More specifically, I will focus on the humerus and how we are using geometric morphometrics to investigate its locomotor adaptation. Oreopithecus bambolii lived between 8.3 and 6.7 million years ago in what is now Italy. The fossils were discovered in Tuscany and Sardinia, which form an insular environment during the Miocene. As mentioned before, Oreopithecus is a controversial primate due to both its phylogeny and its locomotor and manipulative capabilities. Over the years, many different locomotion hypotheses have been proposed based on specific skeletal elements, such as the hand, the pelvis, the vertebra, and the limb proportion. And for decades, researchers have debated its arboreal traits, while others recognize some bipedal traits. Therefore, several questions remain open, and yet no consensus has been reached. As you can see, this is a very old plot, and the questions are still the same. The key to answer this question lies in an iconic fossil, the so-called Sandrone, which is the most complete Oreopithecus skeleton. The fossil is housed in the Geological and Paleontological Museum of Florence. In our project, we perform for the first time a micro-CT scan of the entire fossil in order to digitally restore it and analyze its morphology in details. Our goal is to apply a more comprehensive study of the fossil, shedding new light on this primate with new technique. This fossil is almost complete, but the preservation state is not the best. As you can see in this image, in particular in the lateral view, the long bones are flat, so Sandrone lost his third dimension. In particular, the diaphyses have a great damage, but the epiphyses are in better condition. We are conducting multiple analyses on different skeletal elements, but today I will focus on the proximal epiphyses of the humerus. Indeed, in primates, the shape of the humeral head and muscle attachment sites provide important insight into climbing, suspension, or terrestrial movement. So, to analyze the shape variation, we use landmark-based geometric morphometrics. Following the literature, we place 14 landmarks comparing Oreopithecus to a large sample of extant primates and some fossil, such as Australopithecus sediba and Homo naledi, and some fossil with different locomotion habits. As you can see from this plot, this approach did not reveal a clear locomotor pattern. Oreopithecus is right here. Indeed, the PCA plot showed that Oreopithecus is separated from all other primates, but not due to its locomotor adaptation. This result mainly reflects the taphonomic deformation of the humerus of Oreopithecus, and so traditional geometric morphometrics doesn't work in this case, so we need to change our approach. We focus on three parts of the humeral epiphysis: the head of the humerus, here in blue, the lesser tubercle, here in red, and the great tubercle in green. We isolated this region of the humeral epiphysis directly from the 3D surface model of more than 20 species of extant primates and some fossils. Afterward, we extract centroid for each of these areas, the ones in blue and red and green again, and the centroid of the entire epiphysis, as you can see here in black. The last steps is to calculate the Euclidean distance from the points. So between the centroid of the entire epiphysis in black and the centroid of the three individual areas that you can see here with the blue arrow. And then we calculate the Euclidean distance between the centroid of the three individual areas, as you can see here in yellow. Again, we perform a geometric morphometric analysis on the area, both on the area and the centroid together. The results reveal a distinct separation between major locomotor categories. Brachyters such as Ilobates and Symphalangus clustered together on one side on the positive values of the first PC. while quadrupedal primates, including puppy and macaca, form a clearly different group in the negative value of the first species. In the center, there are the great apes, Homo sapiens, and the fossils. Australopithecus ediba is right here. As you can see, Oreopithecus fall close between the great apes and close to the brachytors. It's important to underline that each area was relative, so was normalized by dividing the total area, the surface of the epiphysis. So this step was crucial to remove the size-related biases. Looking at the B plot, we can see that this plot support the well-documented differences in humeral morphology in primates. So quadrupedal primates exhibit high developed tubercles, both positioned far from the centroid and widely separate from each other. But of course, Oreopithecus show a completely different pattern, and this placement suggests that Oreopithecus has a morphological affinity with brachytors, reinforcing the hypothesis that Oreopithecus was adapted to an arboreal lifestyle. Moreover, all these findings are consistent with our parallel study on linear limb measurement, which placed Oreopithecus among gibbons. But it's not finished yet. We're not finished yet, and we need more analysis. So we are expanding our data set, adding more Homo sapiens and some other missing species of primates. As I already mentioned, we want to create a comprehensive study of the entire fossil. So we are applying a similar method to the other skeletal elements, including cervical vertebra and the hand bones. And then biomechanical study on the metacarpals. And we also study not only the postcranium, but also the cranium, like the mandible. Last but not least, we are also digitally restoring Sandrone, both for museum and educational purpose, contributing to a renewed museum exposition dedicated to Oreopithecus in Florence, but also we try to reconstruct and reto-deform all the epiphyses and plot again all these analyses, try to make, to clear this situation. In summary, Oreopithecus bambolii still remains an enigmatic primate. Thank you for your attention.